Alqubit, IT, as an expression of art. Alqubit, IT, as an expression of art.
Hello world, welcome back. I'm here. Too much time, I'm going into panic mode as today. I need to do every week one live production or 2 times per week. Otherwise, I'm getting lost. Let's begin. Beautiful topic. Very interesting. Professional topic about VxLAN maximum transmission unit calculation. I've been into deep dive on this topic for the last 10 days, and there is always something that I'm thinking when I'm going into deep dive. I'm thinking holistically and trying to reach the three-dimensional functioning of the thing. And there is something very fundamental that wasn't absolutely working how it was expected to be. Let me only double check everything is on. Yes, the live, I'm good to go. Here, VxLAN header. What is the issue? You need to calculate and size end-to-end the communication maximum transmission unit in a way that through the entire pipe there is no fragmentation. Otherwise, in this solution the traffic doesn't pass. And I was thinking about, I was watching countless videos, countless courses, video courses, Cisco Live all the last years. And there is something that wasn't right. And yesterday, or other day, I reached to the point that I had illumination watching on this video that I've got screenshot that is brutally incorrect. There is a fundamental error here. And I arrived to the point that I was from the starting point that where I'm getting into the wrong, I discovered that into the industry it has been wrong with the wrong fundamentals of how things are done. Let's say in this context, CRC, it should not be present here. It should be separated. VxLAN is a way to, this is not a guidance end-to-end or tutoring about VxLAN. It is only reasoning about this specific thing. Encapsulation, maximum MTU, maximum transmission unit, and how to make it work without fragmentation. And everywhere at the beginning, it has been shared years ago in the correct way. And somewhere along the way, something happened because it is difficult topic. In the way, it is not difficult on the fundamental standpoint of view. It is difficult to abstract at multiple point of view in the way that is three-dimensional, correct, and makes sense at the operational level. And what has been done? By simplification has been adopted that VxLAN, it is correct that it occupies 50 bytes. But it is not correct that it starts from the encapsulation outer frame. It starts from the original frame. And I will turn here. This is from this book, Building Data Center with that is super correct. And I have found it immediately when I have reached to the point that my assumption is that there is something fundamentally wrong here. And I reached to the point of illumination that you need to start from the destination MAC address, source MAC address of the original frame. And let's see classical Ethernet flame, how it's done VxLAN. You have your VLAN original and traffic. You can extend this broadcast domain at level 2 Ethernet far away in other city, in other side of the world, whenever you want. You extend this layer 2 broadcast domain. And this classic, they called here classic Ethernet frame. This is the original where you are generating the traffic. And the frame is 6 byte destination, 6 bytes source. Here is written with layer 2 VLAN, but it could be not be present. Even the original, it is optional, as here. There is no one. Ether type and payload. This is the upper level in a sense that where the data is generated, it is upper layer. This is the upper layer of the abstraction of the network, even though it is the inverse. In actuality, it's the lower level, but that's why it's difficult to understand. The upper level, so-called, is the original one that you need to get, encapsulate, transmit someone else, and make it in a way to extend this layer 2. And how is calculated usually into the industry? That is completely wrong. This way. This is the vendor of It is not wrong operationally, but in terms of holistic functioning, it is wrong. You have the original frame here that I have shown here. The original frame. I will go back and forth in order to make it some way comprehensible. The original frame is here. What is VxLAN? It adds 8 bytes of header about the UDP port. VxLAN part, it is reserved. No, I'm getting it wrong. Here, that is reserved. Only 1 bit is used, reserved, virtual network ID, and after that reserved. And this is put on front of the original frame. It is 8 byte that stays there. But maximum transmission unit is fundamental to be able to calculate it in order to not induce fragmentation. And what are doing into the industry? They forget completely about the source. It is the same as here. This thing is, there is a piece here. What is doing the industry? This frame, the header of the Ethernet, original Ethernet, they forget about totally, completely. That is wrong, 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 wrong. You need to keep it into account. VxLAN formation of the overhead starting with this, as it is shown here in this book. And the original, I will show, many years ago, even on Cisco Live, they have shown correctly how it's done. But the good speaker is interpreting the thing without. And from there forward has started this absolutely wrong way of interpreting the entire frame and maximum transmission unit calculation. You have to start from the original frame header. And this is the right overhead. After that, you add 8 bytes for VxLAN. After that, you add 8 bytes for UDP when it is actually the starting of the encapsulation. The encapsulation starting from here. But it is wrongly it is so three-dimensional difficultly that even I kept doubt from during my explanation. UDP, VxLAN. Yes. The payload of UDP is starting with the VxLAN and the entire piece of the old Ethernet. And it is scrapped of CRC and only payload, header, and VxLAN. UDP has this piece of data. and it cannot be skipped of the original header. This is what is starting the encapsulation. One thing is how the protocol is composing the entire thing, but do not confuse the encapsulation with how actually the protocol is working. The entire packaging. The entire packaging is starting with this thing. If here there is, for example, VxLAN, it is scrapped eventually. You can force it, but by default there is no present. This thing is scrapped away. VxLAN is put on front of the original Ethernet, and this becomes the UDP the data frame, how it's called. I'm instead of datagram of UDP, the starting of UDP datagram is VxLAN plus this thing all at once. It becomes one piece of thing. 8-bit is the starting point. And after that, this is what is confusing. After that, you have the outer IP, that into the IP there is a pointer for inner protocol UDP. That is how they are getting serialized and encapsulated. In the IP, there is reference to UDP, and IP is encapsulated into outer Ethernet. But this entire thing, if it is about to transmit end-to-end with this frame, with the same pipe, you need to calculate both headers, Ethernet headers, the original one and the outer one. And why the industry is getting it wrong? Because by default, by simplification, extreme simplification, but totally wrong, let's start from the outer MAC, and this is your frame. Let me show you this nightmare. The wrong way into the industry. VxLAN starting from the outer MAC header, outer IP header, UDP header, VxLAN. Not correct. Returning back. Let me just somehow explain. This outer header and this outer Ethernet. Let's, in my case, in my project that I've been banging my head in the wall for 10 days, why doesn't somehow end-to-end everything is super obvious and correct? In my case, into the project is starting from certain FS switches. It starts that way. After that is going into Meraki. Meraki is stripping away completely this Ethernet. It ends on the Meraki. There is no outer Ethernet anymore. Once this original frame is getting into Meraki. So it cannot be calculated anymore in that way. What is remaining? This is thrown away with this FCS completely strapped away. It remains IP, UDP, VxLAN header, original header of the Ethernet. And the original header of the Ethernet is, let's say, 14 bytes. And this is 8, and this is 8, and this is 20. And it is exactly 15 bytes. It's not from the outer header of the encapsulation that is starting. If you keep the Ethernet end-to-end and you have limited pipe, you need to calculate 14 bytes, 20 bytes, 8 bytes, 8 bytes, and another 14 bytes. You cannot forget about this header here. It is absolutely fundamental. And in this way, that has been illumination. This is wrong. And I immediately made the association. Ignoring those two is completely wrong as well. So, the VxLAN maximum transmission unit calculation and how the VxLAN is done at the protocol level from the very start, you need to start and taking into account those two. Inner MAC, source address, destination address, VxLAN, that it is the payload of the UDP. This is what is fundamental. And this what once arrived on the other side, UDP is stripped away. It needs to be read from the VxLAN header. That's why if you have multiple fragmentation, this piece is missing completely because IP is fragmenting. You miss the UDP header, and on the other side is trying to recompose the fragments. There is CPU at the maximum and you lose completely the traffic. So let's repeat it somehow that can explain it. What is my limitation and why I need to take into account every byte available and not available as well? My Meraki has only 150, I think, or less. And I will need to calculate what actually overhead it has. But this is the last. Let's think. And this is, unfortunately, this is only for people that understand Ethernet to the last byte and bit to understand what I'm trying to explain. You have your payload. Let me try not this. Here, the very basis of the Ethernet. Preamble, frame check sequence. Frame check sequence has only meaning on the physical generation and receiving of the frame. It cannot be transmitted as a package inside of the encapsulated original frame. Doesn't make any sense. And this is why this is completely wrong. There is a separation, and this here C is part of this header here. There is no CRC on the encapsulated frame. It is strapped away where I was to return the same place. And this, every frame that is received and retransmitted in, let's say, for example, on a router, not only that you have to tear down the entire frame and reach to the IP, and after that you go backwards and recompose the frame. But this thing cannot go further from the actual original physical broadcast domain, because it is related to the transmission, actual transmission real time of the frame that is starting with destination address, source address type, Ethernet type, the data. And after that, once everything is transmitted, it is added, calculated, and pushed as a last thing of the frame. So it cannot be done in that way. This thing doesn't make any sense. Cisco Live last year about VxLAN. And that is why it's generating the industry completely out of the topic solutions. There is not such thing as a CRC of the original frame included. No way. But let's suppose that it is corrected here. There is a separation. You cannot skip those two. And I was explaining. I have my subnet that is like a pool of broadcast MAC addresses, and it is operating on two places. For example, distance, kilometers, thousands of kilometers, doesn't make any difference. But I need to transmit, encapsulating this original frame into my limited pipe that I cannot extend with the jumbo frames in any way. I can only limit the frame inwards, limiting its size, not outwards. Let's add 50 bytes to the original 100, 500 bytes of the payload of the original frame, and we are good to go. And those kind of BS explanation can make sense when you have your pipe that you need to resize inwards. You need to extract every single byte where is the exact pipe size, and you need to think what doesn't make sense. CRC inside doesn't make sense. Ignoring MAC addresses from the original frame doesn't make any sense. From there, starting VxLAN actual protocol thinking and data calculation. You need to start from here and after that. So returning into my identical pools that are distance X kilometers, can be 1,000, can be 2, can be whatever, can be in the same server. But they are logically in the same virtual LAN, but it is not mandatory. They can even be on different VLANs, but they need to extend not the number of the VLAN, but the broadcast domain at the layer 2 level of Ethernet. And I'm not explaining now how the VxLAN actually works, how it's configured. This is not the topic. The topic is the calculation is what is shared inside massively by vendors and courses and everything. 99.99 is wrong. You have to include the original 14 bytes of the Ethernet header. And after that, you include till the he is expressed so well. You include the original. Let me hear that, ignoring the VLAN. You include the entire header, the payload, obviously, and the payload is wrongly shown everywhere, 150. This is the correct. Where is this? This is the correct way to show Ethernet payload of the original data. 46 is the very minimum, because the original Ethernet, when it was on the cables, around cables, coaxial, how it's called in English, it needs to stay into the wire for the minimum amount of time in order to arrive everywhere to be heard. So it is minimum 46, and eventually, if it is not 46, it's added a padding in order to arrive to 46. The very absolute minimum is 46 to the maximum of 150, 1500 maximum amount of data, but it can be less, and that's why you can adjust the maximum transmission unit, because you can shorten it in order to be less than 1500. And how it's done? In this way, in this case, not this way. In this case, where is this? That I have shown a few times my reasoning. Let's suppose the Meraki is 100 bytes. That is, it needs to consume 100 bytes. So I already need to shorten my maximum transmission unit by 50. 50 bytes for VxLAN encapsulation. I need to shorten it by other 50. And 40 bytes for 20 for the IP and TCP. When I need end-to-end are ready to transmit the data between different stations of those broadcast domains. It's difficult to show it. 14 bytes. Where? Even here is done the same thing. Original layer 2 frame. You need to put inner MAC header here and starting the calculation from that thing. 14 bytes here every time, except if you can permit yourself to expand the pipe beyond the original 1500. In case you need to reduce inward, it is mandatory to consider those 14 bytes from here. So 14 bytes, 8 bytes, 8 bytes, 20 bytes. It is already 50 bytes, and this is your VxLAN overhead. And I agree in that way. If you have further encapsulation, that the first encapsulation obviously is done with, depends if it is inside hypervisor or inside, as I have here, is done directly by a thing that is a certain firewall. It can be done in endless ways, but in this specific case, you starting from the original MAC address header, Ethernet header, 14 bytes, and here is the actual encapsulation, because inside Meraki, this encapsulation of Ethernet is stripped away. There is no Ethernet during the software-defined one. The external header of Ethernet doesn't exist anymore. So what I need to add, the original MAC frame, Ethernet header, VxLAN, UDP, IP, and the overhead of the software-defined one of the Meraki. And the worst case scenario that you need to take into account is the smallest pipe that you have end-to-end. This it needs to be your limit, and the smallest pipe will be here I need to reduce by 50 inside my Ethernet that I'm not able to expand to 1550 to compensate this header that is missing. I need to reduce it immediately by 50. But after that, this is stripped away. But it is added 100 of the Meraki end-to-end. So I need immediately to add, let's say I will need to do after that the TCP dump of the Meraki, that it uses some TCP dump implementation in order to have actual amount of overhead before being able to see the IP and the UDP. So let's suppose it is 100. I immediately need to set my overhead is 100. Let me see if my explanation was already here. I immediately need to put 100 Meraki. If it is less, I need to put the exact number. If it's more, I need to put the exact number. 50 bytes of VxLAN encapsulation. But not this BS here, but the actual original 50 bytes that starts from the original Ethernet header inside this thing. Here. My 50 bytes here is this. I was still on my path of deep thinking, and something doesn't even artificial intelligence is saying, why are you adding 2 times the 14 bytes? Because it needs to be added 2 times. The first original byte cannot be skipped in any way or form. Eventually, if this Ethernet new frame in somehow use it end-to-end, again, tunnel into the tunnel into the tunnel, triple tunnel, in this case, I will need to add it. Otherwise, before my VxLAN is a tunnel. Meraki is another tunnel. So I'm doing tunnel into the tunnel, but not with the Ethernet encapsulation, new encapsulation. This is only from the generation of the VxLAN protocol. After that, it is losing, it is stripped away by Meraki, and it is only this piece that is what is transmitted on the other side. So it is correct 100 bytes for Meraki, 50 bytes for VxLAN, and 40 bytes when you need to adjust inward the maximum transmission unit of the original broadcast domain of the original Ethernet broadcast domain of the original virtual LAN. There you need to set at the doing the limitation inwards in order to not generating fragmentation. You need to limit the maximum transmission unit at the level 2 and 3, and you need to limit TCP maximum segment size of the TCP IP on how every computer will generate its TCP IP segment. And this is how you solve actually the problem when you have the pipe limited end-to-end, that you cannot expand at any point during the pipe. You can only limit it inwards. And the very last correct reasoning is the original Ethernet frame is super correct, which is part of those 50 bytes plus 100 plus 40. So it becomes 54. No, it becomes 50, 150, 190 bytes less end to end. That is 50 here, 100 on Meraki, and the very inwards to adjust the maximum transmission unit of the of the original maximum transmission unit of the VLAN. That it's not present in any way in form, but you need to take into account to add the functional protocols overheads once the traffic arrives into the destination. You have further overhead, and you need to be sure that no stations of both sides is generating TCP IP or IP that is bigger than the maximum transmission unit feasible for this pipe end-to-end. And I will need to assimilate it in more crystal clear way in order to be able to explain it in easy way, because at this point there is no easy way, because there are three-dimensional of 3 points of view reasoning in order to arrive actually to the overhead. And unfortunately that's why the industry got the shortcut and explain it in totally wrong way. You cannot forget about those headers here. You need to take them into account. And now I show you, this is from 2020. Here on the PowerPoint is shown correctly. The presenter is explaining it in the wrong way. And this is how it has been developed, this thing. And the source and destination of the outer MAC. No, you need to take into account how it's designed here. Inner header. And for the maximum transmission unit end-to-end, you take after that the inner IP 20 and the inner TCP other 20 if there is no options into the header. Otherwise, you need to go even further. Inner depends of TCP IP on the very origin of the traffic. If there is a TCP that is done with options into the header that needs more bigger header, you need to add not 40 for the IP and TCP, you need to add the sum of the actual traffic. This is how it's calculated. And this CRC here in this CRC, those are different CRC. And in some other design pictures, is explained better. CRC new. This is gone. Once it is translated here, this here C is cut. It is gone. This is new. This Ethernet header is new, and it could be temporary only on the very first hop of the transmission of the VxLAN protocol and header and the entire thing. That's why it is complex. It is not simple at all. You need to think dynamically in three-dimensional way on every point of the traffic that is traveling. How actually dynamically it adds and cuts headers, trailers, and everything, and you to stay into the smallest pipe possible in order to have traffic end-to-end without fragmentation. That's why it is complex. And completely ignoring VxLAN, BGP, EVPN, that is order of magnitude of complexity. But this is the basic. If you start with the very basic, that is wrong. Nothing works. You can put whatever you want after that. And I recommend this book. Is golden, absolutely golden, correct. Let's see actually how after that the things are getting complicated, because the original header that here is already done. No, it's actually still present, but you see it is wrong that it's only 50 bytes here, because if you take into account the original and you need to add the outer encapsulation header, you will get more. You will get 64 in case of the original VxLAN is 50, you get 64 as a minimum. And this is very largely adoption of the wrong basis. And this book is correct. It is starting here. This never trust the vendors, because this is the vendor of the validate, trust but validate, validate. Either that the documentation is done by someone that doesn't have the complete comprehension of end-to-end, or in order to not going crazy and trying to explain such an exposition that is three-dimensional matrix of use cases of how possibly they just got do it 50 and you are good to go. No, if you have limited pipe, you cannot do 50 and you're good to go. No. And it's been 10 days of intense deep dive and troubleshooting into my head. And this is the correct way. What I wanted to show. Yes, this is the book. There are few others courses that I have seen on O'Reilly and on LinkedIn Learning that use directly this schematic here from this book, and this is correct. But on Cisco Live, often there are idiosyncrasies that are not precise. There are, I don't know, maybe 15 VxLAN sessions. Guarantee that everyone on each one of those, it is explained into the wrong way. This is in 2020. It is written in the correct way and it is explained into the wrong way. And this is you need to think with your own head, validate end-to-end, learn in your own way. And this is how the real knowledge and robust systems are done, by the engineering methodology that is validation, that you start on the very beginning from the bottom up. You need to write down and make the project grow. And once you have the holistic picture, you need to do interaction. At least 3 minimum in my life I have validated. In order to arrive something to actually work, you need to do minimum 3 interactions of end-to-end, top-down, bottom-up, top-down, bottom-up, top-down, bottom-up, of the complete validation at any point, and match the mechanism, logical mechanism, in order that it works perfectly. And this is what I wanted to share. The basic is you need to include the original inner frame header, and after that you need to adapt based on the specific use case and implementation. There is no rule, put 50 bytes and you are good to go. No. You have your 50 bytes that are those here, not those here. And after that, you need to understand what you're doing and add, subtract, and arrive to the most limited pipe. And unfortunately, you need to keep it that way in order to make it function. You depend of the most limited pipe on the entire thing end to end. And I hope that it is useful. In my project, it's super useful because it will work like crazy for sure. And there are different books, good books on really. You need to subscribe. It is not cheap, but you have all the possible books that has been written on technology, and the courses, video courses as well. And I will stop here with this thing. We will see soon again. I want between tomorrow, it's left only tomorrow, if I can do my programmed video about project methodology. It is related for an episode of a month ago that I thought I have seen everything in my life, but I have never seen project managed. I have seen project done in the craziest thing possible, unreasonable timing, but complex project managed as support ticket. I haven't seen yet, but I have seen it. And so I need to take this thing to share with the community. And my vision is, and I have 38 years in technology, I know what I'm talking about. Projects in security, networking, infrastructure, system integration can never be done with agile BS methodology. It needs to be done in the correct way, end to end, deep dive, validate, test, proof of concept, and after that it will work. If every day you are adopting, let's do the support, and the thing is staying behind your bag and saying, why don't you do multitasking in between? Let's forget. You can, the project, when you have multiple projects, I have done for 25 years multiple projects, you can do, I think, reasonably 4 complex projects in parallel. You can never do projects in multitasking. You can do in multiplexing. You do a complete thing of the project, a chunk of the project from the start to the end, and you reach certain result, develop certain document, reach certain, break certain level of complexity, but cannot be done. I'm doing today in 3 projects. I'm completely, constantly shifting from one to another. You will be doing only BS. You need to do in multiplexing, one by one at a time, but for one person feasibly, I have done for many years, is 4 projects. If you do 5, you need to avoid to sleep, but after that, your capability to deliver a thing is going down. 4 projects is the limit in multiplexing, not in multitasking. And now we return in another video about this thing. And this is for the industry photo community. Do not forget the original Ethernet header into the VxLAN calculation and implementation. Okay, we will see soon again. Thank you very much. And this is my outro, and see you soon. There will be news, there will be change of lifestyle. Let's see how it's going on. Bye, see you soon. Thank you.
Alqubit, IT as an expression of art. Alqubit, IT as an expression of art.